Good morning, everyone. Now, before starting the lesson, the new part of the lesson, organic chemistry, we know that we are in COVID, we are facing COVID-19. So, there are certain guidelines for the COVID-19. The main important thing is wear mask properly and then follow the social and the physical distancing. Do not share eatables and the water bottles with anybody else. And the main important thing is wash your hand with the help of soap and water frequently for at least 20 seconds so that we can easily overcome with the problem of COVID-19. Now come to the part 2 of the lesson organic chemistry. The part 2 is, the first topic of the part 2 is three-dimensional representation of organic molecules. Three-dimensional representation of organic molecule. So, to represent the organic molecule three-dimensionally, if we want to represent the organic molecule three-dimensionally, so there are some conventions by which we can represent the structure very clearly. The first one is normal line. The first one is normal line. And normal line is dash. This is a dash. This is the representation for the normal line. So the normal lines always shows the group lying in the plane of a paper. So if we want to designate that group which is lying on the plane of paper, so for that we have to use normal line, and this dash is the representation for the normal line. Now the second one is the solid wedge. Solid wedge. So this is the representation for the solid wedge. This is the representation for the solid wedge, and the solid wedge shows the bond projecting out of the plane of paper. The bond which are projecting out of the plane of paper and towards the observer. So this is the wedge line. Now the third one is dashed wedge. Third one is dash wedge. Now this is the dash wedge. Next is the dash wedge. So to represent the dash wedge, this is the representation. This is the representation for the dash wedge. So this one is the representation. The small lines are the representation for the dashed wedge, and the dashed wedge also show the bond projecting out of the plane of paper. Bond projecting out of the plane of paper, but it is always away from the observer. This one is towards the observer. Solid is towards the observer, whereas this one is away from the observer. This one is away from the observer. So these are the representation, main important representation for the three-dimensional structure of the organic molecule. Now let us take the example of CH4. The CH4 is methane. The name of the CH4 is methane. So let's draw the structure for the methane. So if you want to draw the three-dimensional structure for the methane is, so that is C, H, here it is H. Now this one is H, and this is also H. So one carbon atom and four hydrogen atom. And among these four hydrogen atom, these two hydrogen atom are connected to the carbon atom with a normal line, because this is the representation for the normal line, whereas the one hydrogen atom, this one hydrogen atom which is towards the observer, it is connected with a solid wedge, and this hydrogen atom is connected with the dashed wedge, and it is out of the plane of the paper and it is away from the observer. So by this way you can easily represent any of the molecule, any of the organic molecule three-dimensionally. That is three-dimensionally. So these two bonds, this CH bond and this CH bond, these bond in the plane of paper. These bond in the plane of paper, and this is a dashed wedge, and this one is solid wedge. So this is the representation. This is the way by which we can represent the organic molecule three-dimensionally. Now the next topic is classification, that is classification based on carbon skeleton. Classification based on carbon skeleton. So first of all we have organic compound. This is the organic compound. So the organic compound, or we can say that it is a hydrocarbon or its derivative. Hydrocarbon or its derivative. So the organic compound are divided into two categories. One is acyclic. This is the acyclic or open chain compound. Acyclic or open chain compound, and this one is the cyclic or closed chain compound. So the organic compound is first classified into two categories. One is the acyclic or open chain. Now it is clear from the name that these are the open chain compound. For example, CH3, CH2, CH3. So this is a open chain compound. And the second category is cyclic or closed chain compound. So cyclic means in the form of a ring. They are in the form of a ring. For example, CH2, 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 and this bond. So this is in the form of a ring. This is in the form of a ring. So this is a acyclic or the open chain compound. These are the cyclic compound or the closed chain compound. Now the cyclic compound, this category, the cyclic compound is classified into two subcategories. The first one is homocyclic. The first one is homocyclic and the second one is heterocyclic. cyclic. The first one is the homocyclic and the second one is the homocyclic compound. So the homocyclic compound are also known as carbocyclic compound. The homocyclic compound are also called carbocyclic compound. It means they have chain of only carbon atom. Carbo means carbon. Carbocyclic. So it has a chain of only carbon atom. It means that in a chain, if we are talking, cyclic means a chain. So if we are talking about the chain, so the chain contain only carbon atom. And the second one is the heterocyclic compound. So hetero means different. Hetero means different. So they have foreign atoms like nitrogen, oxygen, sulfur, phosphorus. X stand for the halogen in carbon chain. In carbon chain. Homocyclic means they contain a chain, they contain a cyclic compound, a cyclic structure, and that cyclic structure is made with only carbon, whereas in case of the heterocyclic compound, they contain the carbon atom in the chain, in the cycle, as well as nitrogen, oxygen, phosphorus, sulfur or halogen in that chain. So this is the homocyclic. Cyclic is divided into two categories. The first one is the homocyclic and the second one is the heterocyclic. Homocyclic and the heterocyclic. So now the homocyclic. Again, the homocyclic compounds are divided into two categories. The one is alicyclic compounds and the second one is the aromatic compounds. Homocyclic is further divided into two categories, alicyclic compound and aromatic compound. So alicyclic compound are those compound like this one. This is the example of alicyclic compound. This one is the example of alicyclic compound. But if we are talking about the aromatic compound, it means we are talking about the benzene ring. If we are talking about the aromatic compound, it means that we are talking about the benzene ring, because the first member of the aromatic family is the benzene. Benzene is the parent member. The first member is benzene. It means we are talking about the benzene. It means it contains the structure of the benzene. So it is also called aromatic compound is further divided into two categories. One is the benzenoid. One is the benzenoid compounds. It means those compound, benzenoid compound means those compound in which the main structure is of benzene. The main structure is of benzene. And the second one is non-benzenoid compound. Non-benzenoid compound means they have a cyclic structure, they have a ring structure, but they do not contain benzene ring. They do not contain benzene. This is the structure for the benzene ring. This is the similar as the hexagonal structure, only there is a nucleus, that is the bond. This circle shows the position of the bond. Now the next topic is classification of organic compounds. Classification of organic compound based on functional group. Classification of organic compound based on functional group. So before starting this topic, let us discuss about the functional group. What are the functional group? We have already discussed this topic, functional group. So an atom or a group of atom. An atom or a group of atom present in an organic compound. Present in an organic compound which is responsible for the chemical properties of the compound, which is responsible for the chemical properties of the compound, is called functional group. And what are the functional group? What are the types of functional group? We have already discussed, that is alcohol. We have discussed in the previous lecture, that is alcohol, carboxylic acid, or aldehydic group, ketonic group. We already have discussed about types of the functional group. So the functional group gives the chemical property of the compound. It gives the it is responsible, the functional group is responsible for the chemical property of the compound. Now next heading under this topic is homologous compound or homologous series. Sorry, not compound, homologous series. Actually, this is this topic we have studied in our previous class, that in 10th, that the difference is CH2 group. When one compound is differ from another compound by CH2 group, that is called the homologous series, or the group or series of a compound having characteristic functional group is called homologous series, and the member of the series are called the homologous. The series is called the homologous series, but the member are called the homologous. For example, alkane, that is CH4. This is alkane. If that is this is the alkane series, and this is called methane. So if you want to write the homologous series of the alkane, so one is CH2, so add, that is CH4, so add CH2 in here. Then next is C2H6, that 1C plus 1C, that is 2C, 4 plus 2 is equal to 6. Then again the next member is add CH2 group over this, C3H8. So this is the homologous series of the alkane. So by this method you can write down the homologous series for any of the organic compound, whether the functional group is present or not. So there are certain general characteristics of the homologous series. So these characteristics is, the first one is all the members of the series. For example, this is a series. So all the member of the series contain same elements. Now look at here, only the number is increasing. Here the carbon is 1, here the carbon is 2, here the carbon is 3. Here hydrogen is 4, here 6, and here 8. But the element are same. Only carbon and hydrogen. Only carbon, hydrogen. Carbon, hydrogen. Okay. So all the member of the series contain the same element and the functional group. For example, if there is a functional group, if functional group is present here, so the functional group will also not change. The element or the atom remain the same. Only the number is increases. The number is increased, but the elements are same. So this is the first concept. Now the second is all the member can be represented by a single general formula. There is a formula to represent all the member, that is CnH2n plus 2. This is the formula. CnH2n plus 2. This is the general formula, and this is the general formula for alkane. That is we know that it is a saturated hydrocarbon. So this is the general formula for the alkane, and all the member are represented by this formula. Apply this formula for all the member, you can easily find out the homologous series. Now next is the molecular formula of each homologue differ from the previous by CH2 group. Now look at here, this one is CH4. Now the next member is C2H6. So there is a difference between these two compound, and the difference is of CH2 group. So this one is differ from this one only by CH2 group. So this is the main thing. This is a very important, this is a keyword. This is a keyword for the homologous series, that one member, the second member, is differ from the previous member by the CH2 group. So this is all about the homologous series. So on the basis of the functional group, we have already discussed we have already discussed about the functional group, that functional group represent the chemical property of the compound. So on the basis of the functional group, organic compound are classified into various categories. The organic compounds are classified into the various category. So for example, that is organic compound. So how we classify the organic compound? There are so many ways to represent the organic compound. The first one is double or triple bond. Double or triple bond. So if the double bond is present, and what happens if the triple bond is present? So when there is a double bond in between the carbon, two carbon atom, and the second condition is triple bond in between the carbon atom. If the condition is like this, the double bond is present in between the carbon atom, so it is called alkene. And if the triple bond is present in between the carbon atom, it is alkyne. So this is the first way to classify the organic compound. Now the second is halogen derivative. Second one is halogen derivative. Now the halogen derivatives are classified into two categories. The first one is haloalkanes, and the second one is haloarenes. The first one is haloalkane and the second one is haloarene. Now it is clear from the name that when the alkyl group is attached to the halogen, here R is the symbol to represent the alkyl group and X is the symbol to represent the halogen. These R and X are nothing but R is the representation. This is a symbol for the alkyl group and X is the symbol for the halogen. So when the alkyl group is attached to the halogen, so it is termed as a haloalkane. And when that is C6 H5X, it means when the benzene ring is attached with the halogen, so it is termed as the haloarene. It is termed as the haloarene. So this is the main difference between the haloalkane and the haloarenes. So this is the second way or the second classification. Now next classification is oxygen containing compound. That is oxygen containing compounds. Oxygen containing compound. So on the basis of the oxygen containing compound, there are various subheading, there are various sub-classification. When the oxygen is present within the organic compound, so there are various classification. The first one is alcohol. The first one is alcohol, that is ROH. Alcohol, that is ROH. Here OH means alcoholic group. When the alcoholic group is present, that OH, R is the alkyl group, OH is the alcoholic group. So this classification is the alcohol. Now the second classification is the ether. Ether, alkyl group, oxygen, alkyl group. This is the representation for the ether. It is a functional group. It is a type of a functional group. Next is the carboxylic acid. That is RCOOH. This is the representation for the carboxylic acid, RCOOH. When the COOH group is present in any organic compound, it means it contains the carboxylic group. The carboxylic group is present with it. So it is a carboxylic acid. Then carbonyl group. Carbonyl group. Now in case of the carbonyl group, we can classify it in the two way. The one is the aldehyde and the second one is the ketone. So CHO, if CHO is present with any organic compound, it means it belongs to the family aldehyde, and if CO is present, so it belongs to the ketonic group. It is a ketone. It is a ketone when CO group is present. So this is the classification on the basis of oxygen containing compound. Here, look at here, in all the functional group the oxygen is present. Here oxygen is present with the hydrogen, that is ROH. Here ROR, again the oxygen is present. Here RCOOH, oxygen is present. Look at here, this is the aldehyde, that is CHO, oxygen is present. And in case of the ketone, CO, here also the oxygen is present.